In question 1, the function f is defined by f of x is equals to x square minus 4x plus 8 for x as an element of real number. In part 1, we have to express x square minus 4x plus 8 in the form x minus a whole squared plus b. So we can first expand the expression x minus a whole squared. This will become x squared minus 2ax plus a squared plus b. And to find the values of a and b, we can compare the coefficients. So on the left hand side, it is minus 4. On the right hand side, it is minus 2a, the coefficient of x. So we can write minus 2a will be equals to minus 4. So a will be equals to positive 2. To find the value of b, we can compare the constant terms. On the left hand side, it is 8. And on the right hand side, it is a squared plus b. So a squared plus b will be equals to 8. A is 2 squared, so this will become 2 squared plus b equals to 8. B will be equals to 8 minus 4, so that will be equals to 4. So we can write this as x minus 2 whole squared plus 4. In part 2, it says, hence find the set of values of x for which f of x is less than 9. So we know that f of x can be written as x minus 2 whole squared plus 4 as less than 9. Taking 4 on the left hand side, we'll get x minus 2 whole squared is less than 9 minus 4 will be 5. So now taking the square root of 5, we will get x minus 2 whole squared. So taking the square root, that will become a square root of 5. So we can write this as x minus 2 is less than square root of 5. Now, with the square root sign, we get a plus, and with the square root, we get a plus and minus. So we can write x minus 2 will be less than plus minus root 5. And taking 2 on the other side, so that will become x will be less than plus minus root 5 plus 2. Now, as we have to give the correct inequality signs as well, and if we make a quadratic curve over here, we know that the upper root will be, so that will be root 5 plus 2, and the lower value will be minus root 5 plus 2. Now, as this was x is less than, and which means it will be a negative value, or if you bring it on the left hand side, this will become x plus, so this will become a negative up here. So we can write this as, if we rearrange this, this will become x minus root 5 minus 2 as less than 0. And this will be a plus minus sign. Now, as it has to be less than 0, it means that it will be between these 2 points. As between these 2 points, it is a negative or less than 0. So we can say that x will be greater than the lower value, which is minus root 5 plus 2, and x will be greater. So x will be greater than the negative, the lower value. So this will be x is greater than minus root 5 plus 2, and it will be lesser than the upper value. So it will be x is less than root 5 plus 2. So the two values of x in the exact form will be x greater than minus root 5 plus 2 and x less than root 5 plus 2. In question 2, part 1, in the binomial expansion of 2x minus 1 upon 2x to the power 5, the first three terms are 32x power 5 minus 40x cubed plus 20x. We have to find the remaining three terms of the expansion. Now, the expansion formula for a plus b to the power n, we know that is a power n plus nc1, a to the power n minus 1, b to the power 1 plus nc2, a to the power, so this will be n minus 2 and b to the power 2 and so on. Now we already have the first three terms. It means we already have a to the power n, nc1 and nc2. So the remaining three terms will be using nc3, nc4 and nc5. Now the expression is 2x minus 1 upon 2x to the power 5. As we already have the first three terms, so we'll start off with 5c3. So this will be 5c3, a is 2x into 5 minus 2, and b is minus 1 upon 2x, so that will be to the power 3. Then we'll have the next term, which is 5c4, so this will become 2x into 5 minus 4 and minus 1 upon 2x to the power 4. And the last term will be 5c5, 2x to the power 5 minus 5, and this will be minus 1 upon 2x to the power 5. Simplifying this, we will get, so 5c3, if we substitute this in the calculator, that will be equals to 10. This will be 2x whole cube, so that will become 8x cube into minus 1 upon, so this is 5 minus 2, 3, and this will be So this should have been a 5 minus 3 up here. So this will become 5 minus 3, which will become a whole squared. So 2x whole squared will become a positive 4x squared. So this will be a 4x squared up here, not 8x cubed. So this, there will be a slight correction over here. This will become 4x squared into, and this will become minus 1 upon 8x cubed plus 5c4. So 5c4 in the calculator, that is 5. This will become 2x to the power 1, so that will be 2x, and minus 1 upon 2x to the power 4, so that will become a plus 1 upon 16 x to the power 4. And finally, the last term, which was 5c5. So 5c5 is 1. This will become a power 0, and we'll have minus 1 upon 2x to the power 5. So that will be 32x to the power 5. Simplifying this, so that will be 40 upon 8. So that will become minus 5. And x squared and x cube will cancel out. So we'll have minus 5 upon x plus this will become 8 upon 16, or we can cancel this out. This will become 5 upon 8. So this will be 5 upon 8, and x power 4 will cancel. So this will become x cube, and this will be plus minus minus. So this will be minus 1 upon 32 x to the power 5. Now, once we have the expansion in part 2, it says, hence find the coefficient of x in the expansion of 1 plus 4x squared multiplied by 2x minus 1 upon 2x to the power 5. So first we can write the complete expansion of this expression, 2x minus 1 upon 2x. So this was 32x to the power 5 minus 40x cubed plus 20x. And then the next terms were minus 5 upon x plus 5 upon 8x cubed and minus 1 upon 32x to the power 5. Now we have to look for terms which when we multiply, they give us the power of x as 1. So we can multiply 1 with 20, that will give us a 20x. We can multiply 4x square with minus 5 upon x. So multiplying 4x square with minus 5 upon x, that will give us a term in x. And there's no other term that will give us a term in x, so that these will be the only two terms. So this will become 20x, this x will cancel out, and this will become a minus 20x. So the term in x will be, the coefficient of x will become a 0. As 20x minus 20x is a 0x, so the coefficient, the final answer will be equals to 0. In question 3, the diagram shows triangle ABC, which is right angled at A. Angle ABC is equals to 1 upon 5 pi radian, and AC equals to 8. The point D and E lie on BC and BA respectively. The sector ADE is part of a circle with center A and is such that BDC is a tangent to the arc DE at D. So in part 1, we have to find the length of AD. Now to find the length of AD, we know that this angle is 1 upon 5 pi. This is 90 or pi upon 2. So to find angle ACB first, so ACB will be equals to, so as this is pi upon 2, so the sum of these two will also be pi upon 2. So we can write that angle ACB will be pi upon 2 minus pi upon 5. Taking the LCM, which will be 10. So this will become 10 is equals to 5 pi minus 2 pi. So this angle will be 3 pi upon 10. Once we have this angle as 3 pi upon 10, the angle ACD or ACB, we can use opposite over hypotenuse, which is sine. So sine of 3 pi upon 10 will be equals to AD divided by the hypotenuse, which is 8. So AD will be equals to 8 multiplied by sine of 3 pi upon 10. And we'll make sure to keep our calculators in radian mode. So sine of 3 pi divided by 10 and then multiplying it by 8, this will become 6.472. So the length of AD is 6.4721 centimeters. And as we have to give our answer to 3 significant figures, the final answer will be 6.47 centimeters. In part 2, we have to find the area of the shaded region. Now, the shaded region basically consists of the sector AED and the triangle ADC. Now, to find the area of the sector, we apply the formula half r squared theta. So for that, we will need this angle, and the radius will be the length of AD, which we already know, which is 6.47. So as this angle was 3 pi upon 10 in the previous part, first we can find this angle. So to find angle DAC in the first step. So angle DAC will be is equals to pi upon 2 minus 3 pi upon 10. Taking the LCM, that will become 5 pi minus 3 pi upon 10. So that will be equals to 2 pi upon 10 or pi upon 5. As this angle is pi upon 5, we know that as this complete angle was pi upon 2, so angle BAD will be equals to, so BAD will be pi upon 2 minus pi upon 5. Subtracting this, we'll again get the LCM as 10. So this will become, so multiplying this by 5 and multiplying this by 2, we'll get 5 pi minus 2 pi, which is equals to 3 pi upon 10. So now finding the area of the sector, which is half r squared theta. So area of sector will be is equals to, the formula is 1 upon 2 r squared theta. So we'll get 1 upon 2 into r squared. R was 6.472. We'll use the complete value whole squared multiplied by the angle, which is 3 pi upon 10. So substituting this in the calculator, we'll get 6.472. So 6.472 multiplied by 3 pi divided by 10. And we'll have to whole square 6.472 first. So 6.472 whole squared multiplied by, so this is 3 pi multiplied by 10 and then dividing it by 2. So just a correction, 3 pi divided by 10 multiplied by 6.47 whole squared and then dividing this by 2. This will be 19.726 centimeter squared. And now finding the area of the triangle. So the area of triangle will be, we'll use the formula half AB sine C. We know that the two lengths are 6.47, the length of AD and AC, which is 8. So the two lengths will be half into 6.47 into 8 into sine of this angle DAC, which we found was pi upon 5. So this will become sine of pi upon 5. Now finding sine of pi upon 5, so this will become sine of pi divided by 5 multiplied by 8 multiplied by 6.47 and then dividing it by 2. This will be 15.212118 and the total area of the shaded region will now be, so the total area will be is equals to 19.72 plus 15.2118. So adding 19.72, this will become 34.93 centimeter squared. And as we have to give our answer to three significant figures, so the final answer will be 34.9 centimeter squared. In question 4, function f is defined by f of x 48 upon x minus 1 for x 3 till 7. The function g is defined by g of x equals to 2x minus 4 for x a till b, where a and b are constants. We have to find the greatest value of a and the least value of b, which will permit the formation of the composite function gf. Now, if you are forming the composite function gf, it basically means that in the function g, 2x minus 4, x will be replaced by the function f. So we'll be writing the composite function gf like this. So this will become 2 into 48 upon x minus 1 minus 4. Now this is basically the values of x for the function g. And as we already have the function f from 3 till 7, we can find the maximum and minimum value of this expression 48 upon x minus 1. So if we find f of 3, that will become 48 divided by 3 minus 1. That will be equals to 24. And if we find f of 7, which will be 48 divided by 7 minus 1, so that will be 48 upon 6, which is 8. So now we know that the value of a will be 8. So this will be the value of a, and this will be the value of b for the function g. In part 2, it says that it is now given that the conditions for the formation of gf are satisfied. Find an expression for gf of x. Now to find an expression, well, we already wrote the expression for gf of x. So gf of x will be equals to 2 into 48 upon x minus 1 minus 4. We can expand this and write it as 2 into 48 is 96. So this will become 96 upon x minus 1 minus 4. In part 3, it says find an expression for GF inverse. So as you already have GF in the previous part, so to find the inverse, first you can write y in place of GF of x and write it as y equals to 96 upon x minus 1 minus 4. Now exchanging the values of x and y, this we can write it as x equals to 96 upon y minus 1 minus 4. So taking 4 on the other side, this will become x plus 4 is equals to 96 upon y minus 1. Cross multiplying, so we can write it as y minus 1 will be is equals to 96 upon x plus 4. And finally, taking 1 on the left hand side, this will become y is equals to 96. So this was x plus 4 up here. So this will be x plus 4. So this will be 96 upon x plus 4. And this minus 1 will come on the right hand side and become a plus 1. So the expression for GF inverse, will be equals to 96 upon x plus 4 plus 1. In question 5, two heavyweight boxers decide that they would be more successful if they competed in a lower weight class. For each boxer, this would require a total weight loss of 13 kgs. At the end of week 1, they have recorded a weight loss of 1 kg, and they both find that in each of the following weeks, their weight loss is slightly less than the week before. Boxer's A weight loss in week 2 is 0.98, and it is given that his weekly weight loss follows an arithmetic progression. In part 1, we have to write down an expression for his total weight loss after x weeks. Now, as it is an arithmetic progression, the sum to n terms of an arithmetic progression is given by n upon 2 into 2a plus n minus 1 into d. So as we have to find the total weight loss after x weeks, so we can write this expression as for the sum of x weeks, this will be x upon 2 into 2 into 1 plus n minus 1. So this will become x minus 1. And as in the second week, the weight loss was 0.98. So the common difference will be, so we can write d will be equals to 0.98 minus 1, which is equals to minus 0.02. Simplifying this, we can write this as the sum will be sum of after x weeks, it will be x upon 2 into, this will become 2 plus, so minus 0.02 into x will become minus 0.02x, minus 1 into minus 0.02 will become a plus 0.02. Simplifying this, we can write this as x upon 2 into 2.02 or minus 0.02x plus 2.02. And now multiplying by x and dividing by 2. So this will become 0.02x squared divided by 2. So this will become minus 0.01x squared. And this will be 2.02 divided by 2. So that will become a 1.01. So the sum after the total weight loss after x weeks will be 0.01x squared plus 1.01. Now in part 2, it says he reaches his 13 kg target during week n. Use your answer to part 1 to find the value of n. Now we already know that after x weeks, the total weight loss will be given by the expression minus 0.01x squared plus 1.01. And this was also multiplying by x, so this will be 1.01x. And the total should be equal to 13, so we can write it equals to 13. We can rearrange this quadratic equation to write it as 0.01x squared, making it a positive. Taking it on the right hand side, this will become minus 1.01x plus 13 equals to 0. Now using a calculator to solve the quadratic equation, so we can substitute the value of a as 0.01, the value of b as minus 1.01, and the value of c as positive 13. So substituting this in the calculator, one of the values of x that we'll get will be 85.85, and one of the values will be 15.14. Now we'll take the first value, basically that when it reaches a 13 kg target, so that will be 15.14. But as the value is 15.14, it means that it will reach its target in the 16th week. So the final answer will be 16. In part 3, it says boxer's B weight loss in week 2 is 0.98, and it is given that his weekly weight loss follows the geometric progression. Part 3 says calculate his total weight loss after 20 weeks and show that he can never reach his target. So as it is a geometric progression, the sum of n terms of a geometric progression is given by, so that is a into 1 minus r to the power n upon 1 minus r in case where r is less than 1. So as his weight loss in the second week is 0.92, so the value of r will be the second term divided by the first term. So that will be equals to 0.92. Finding the sum after 20 weeks, so that will be equals to a is 1 into 1 minus, this will become 0.92 to the power 20 divided by 1 minus 0.92. Substituting this value in the calculator, so the sum after 20 weeks will be equals to, this will be equals to 10.1 kg. And now as we have to show that he can never reach his target, so basically it is talking about even if n is very large, what will the sum be? So that means we have to find the sum to infinity. So the formula for sum to infinity is a upon 1 minus r. And just to understand this, we know that the sum formula is a into 1 minus r to the power n upon 1 minus r. Now, if r is less than 1, so let's say in this case it is 0.92, and we write a power up here, which is, let's say, 30 over here. So this value will keep on decreasing. And if we keep on, let's say, writing a bigger value, let's say we write 0.9 to the power 100, it will even become smaller, and it will basically become a 0 for very high values of n. So that's why this becomes a 0, r to the power n. So the sum of infinite terms, or sum to infinity, is a upon 1 minus r. So finding the sum of infinite terms, that will become 1 divided by 1 minus 0.92. Substituting this value in the calculator, that will become 1 divided by 0.08. And that will be equals to 12.5. Now, as he had to reach the target of 13 kgs, the sum to infinite term is 12.5. So we can write as 12.5 is less than 13. It shows that he can never reach his target. Question 7, the coordinates of 2 points A and B are 1, 3 and 9, minus 1, and D is the midpoint of AB. A point C has coordinates x, y, where x and y are variables. In part 1, we have to state the coordinates of B. So in the first step, as it is the midpoint of AB, so we'll use the formula x1 plus x2 upon 2. So that will become 1 plus 9 upon 2, and y1 plus y2 upon 2. So that will become 3 plus minus 1 upon 2 for the midpoint of AB. Simplifying this, we'll get 1 plus 9, 10 upon 2, which is 5, and 3 minus 1, 2 upon 2, 5 and 1. So these are the coordinates of D. In part 2, it is given that CD squared is equals to 20. We have to write an equation relating x and y. Now we already have the coordinates of D, which are 5, 1. We can assume that the coordinates of, well, it is given in the question that the coordinates of C are x, y. So the distance formula is, so if you're finding the distance of CD, that will be x2 minus x1 whole squared plus y2 minus y1 whole squared. So we can take, this is x1, y1, and this has x2 and y2. So CD will be is equals to square root of, so that will become x minus 5 whole squared plus y2, so that will become y minus 1 whole squared. And as CD squared is equals to 20, and we'll whole square both the sides to get rid of the square root sign. So we'll get CD squared is equals to x minus 5 whole squared plus y minus 1 whole squared. And as CD squared is already given as 20, so we can write the final equation as x minus 5 whole squared plus y minus 1 whole squared, and that will be equals to 20. In part 3, it says it is given that AC and BC are equal in length. Find an equation relating x and y and show that it can be simplified to y equals to 2x minus 9. Now we have the coordinates of A, which are 1, 3. We have the coordinates of B as 9, minus 1. And the coordinates of C are x and y. So as the lengths are equal, so we can apply the distance formula to AC and BC and equate the two equations. So first finding the distance of AC, so that will become square root of x2 minus x1, so that will become x minus 1 whole squared plus y2 minus y1 will become y minus 3 whole squared, and that will be equals to the square root of the distance. So the distance of BC will become x minus 9 whole squared, and this will become y minus 1 whole squared. So that will become a y plus 1 whole squared. Now we'll whole square both the sides, and the square roots will cancel out with the whole square. So we'll get x minus 1 whole squared plus y minus 3 whole squared. And expanding this, we'll get x squared minus 2x plus 1. Expanding y minus 3, that will become y squared minus, so that will become 6y plus 9. Expanding this will become x squared minus 18x plus 81. And this will become y squared plus 2y plus 1. Now, on both the sides, we have x squared and x squared, so they will cancel out, as if we take the x squared on the right-hand side or the left-hand side, it will cancel out. The y square will cancel with y squared. Now we can bring this 18x and the 2y on the left-hand side, so can be written as, so this will become minus 2x plus 18x. This is a minus 6y, and that was a plus 2y, so this will become a minus 2y is equals to, this is 81 plus 1, and this is a 9 plus 1, 10, so this will become a minus 10. Simplifying this, we'll get 16x minus 8y is equals to 81 plus 1 is 82 minus 10, that will become 72. And as we have to give it in the form y equals to 2x minus 9, first we can divide the whole equation by 8. So this will become 16x upon 8 will become 2x minus y is equals to 72 divided by 8 is 9. Taking y on the right hand side, we can write the final equation as y equals to 2x minus 9, as we had to prove in the question. In part 4, it says using the results from part 2 and 3, we have to find the possible coordinates of C. Now, one of the equations we got was x minus 5 whole squared plus y minus 1 whole squared, and that was equals to 20. And the second equation we got from the third part was y equals to 2x minus 9. Now, as x and y are the coordinates of C, we can solve these equations simultaneously to find the value of x or y. So using the substitution y equals to 2x minus 9, we can first write this equation as x minus 5 whole squared, and in place of y, we'll get 2x minus 9 is equals to 20. Simplifying this, we can write it as x minus 5 whole squared plus 2x minus 10 whole squared equals to 20. And now expanding the expression, we'll get x squared minus 10x plus 25. This will become 4x squared minus, so this will become 10 times 2, and multiplying by 2, that will become a minus 40x plus 100 is equals to 20. So x squared plus x squared, that will become 5x squared minus 10x minus 40x will become minus 50x. 100 plus 25 is 125, and when we can bring the 20 on this side, so we can now write this equation as 5x squared minus 50x, and this will become 125 minus 20, which is plus 105 equals to 0. To simplify this equation, we can divide the whole equation by 5 and write it as x squared minus 10x plus 21 equals to 0. We can use our calculators now to solve this quadratic equation, or we can just factorize it by using the factors 7 and 3. So this will become minus 7 and minus 3 equals to 0. So the two values of x will be equals to 3 and x will be equals to 7. Once we have the x values, now we can find the y values by substituting this x value in either of the two equations. So using the simpler equation, which is y equals to 2x minus 9, so this will become 2 into 3 minus 9, and this will become y is equals to 2 into 7 minus 9. So it's 6 minus 9, the y coordinate will become minus 3, and over here the y coordinate will become 14 minus 9, that is 5. So we can write that the possible coordinates of C can be 3 comma minus 3 and 7 comma 14. So this will become, okay, so that is 14 minus 9, that is equals to 5. So this will become 14 minus 9, which is equals to 5. So this will be 7 comma 5. Question 8, a curve is such that dy dx is 3x squared plus ax plus b. The curve has stationary points at minus 1 comma 2 and 3 comma k. We have to find the values of the constants a, b, and k. Now, as we already know that the curve has stationary points, that means that the dy dx will be 0 if we substitute x equals to minus 1 and x equals to 3. So we already have the expression for dy dx, which is 3x squared plus ax plus b, and that will be equals to 0 if it is a stationary point. Now substituting x equals to -1 into the equation, we'll get 3 into -1 squared plus a into -1 plus b equals to 0. Simplifying this, we'll get 3 minus a plus b equals to 0. Now substituting x equals to 3 into this equation, this will become 3 into 3 squared plus a into 3, and this will become a plus b equals to 0. So this will become 27 plus 3a plus, so this is a plus b equals to 0. Once we have the two equations, we can solve them simultaneously to find the values of a and b. So the first equation, we can write it as minus a plus b equals to -3, taking 3 on the right hand side. And the second equation will be 3a plus b is equals to -27. Now to solve this equation simultaneously, we can multiply this equation by -1 and keep this equation as it is. So we can rewrite these equations as the first equation will remain the same. The second equation will be -3a minus b is equals to +27. So b and minus b will cancel out. This will become a -4a is equals to this will become a +24. So a will be equals to -6. Once we have the value of a, we can substitute this value of a into either one of the two equations to get the value of b. So the first equation was -a plus b equals to -3. As a is -6, so we'll get minus into -6 plus b equals to -3. So this is a +6 plus b is equals to -3. So b will be equals to -3 minus 6. So the value of b will be -9. Now, once we have the values of a and b, we can rewrite the expression for dy dx, and that is equals to, it was 3x squared plus ax, so that will become -6x, and that was a plus b, so that will become a -9. Now to find the value of the constant k, first we'll integrate the equation and find the equation, integrate the expression for dy dx and find the equation for the curve. Once we have the equation of the curve, we can then substitute x equals to 3 to find the value of k, which is the y coordinate. So in the next step, we'll integrate both the sides. So integrating dy dx, that will become y is equals to, so 3x square will become 3x cube upon 3. This will become 6x square upon 2. And integrating 9, that will become 9x plus c. So we can simplify this equation to write it as x cube minus 3x squared minus 9x plus c. Now to find the value of c, we need the x and the y coordinates, which we already have from the first point, which is -1, 2. So substituting -1, 2 into the equation. So this will be 2 is equals to -1 cube minus 3 into 1 squared minus 9 into 1 plus c. So this will become 2 is equals to -1, and this was a -1 squared. So this will become -3. And this is also a -1 up here. So this will become a +9 plus c. So we'll get 2 is equals to -4 plus 9, which is, so this will become -1 -3 -4 -4 plus 9 is a +5 plus c. So c will be equals to 2 minus 5, which is equals to -3. So once we have the value of c, we can write the equation of the curve, that will be y equals to x cube minus 3x squared minus 9x minus 3. And now to find the value of k, the coordinate was 3, k. So now substituting x equals to 3 over here, so the value of y will be k. So k will be is equals to 3 cube minus 3 into 3 squared minus 9 into 3 minus 3. Simplifying this, we'll get 27 minus 3 into 9, which is 27 minus 27 minus 3. So 27 and 27 will cancel out, and we'll get -27 minus 3, which is -30. So the value of k will be equals to -30. In question 9, the function f of x is p sine squared 2x plus q, where p and q are positive constants. The diagram shows the graph of y equals to f of x. In terms of p and q, we have to state the range of f. Now, the range of f is basically the minimum value and the maximum value. So this value up here will be the maximum value, and this value up here will be the minimum value. So we have to give these values in terms of p and q. Now, to understand this, we first have to understand what the graph of a sine x graph looks like. So if we draw a graph of sine x, it will basically look like this. And if we whole square it, so this negative part is reflected into the positive part of the graph. So that graph now basically, after whole squaring, it looks like this. Now this is basically the amplitude of the expression, and this is, in this case, this will be P, as this represents the amplitude of the sine graph. And this will also be P. Now, this Q represents the translation of the graph in the y direction, and we can see that this graph has basically moved upwards in the y direction. So this translation or the movement in the y direction is being represented by Q. So this value will be equals to Q. And we know that this, as this was equals to P, the amplitude, so this is basically P. So the highest part will basically be P plus Q. So f of x will be less than or equals to P plus Q, and it will be greater than or equals to Q. In part 2a, we have to state the number of solutions of the following equations. F of x is equals to P plus Q. Now, P plus Q is basically a constant, and we have it up here. So if we draw a straight line from P plus Q, it will be intersecting the graph. So if you make a straight line from P to Q, it should make a straight line. It should intersect the graph at 2 points. So the number of solutions in this case will be equals to 2. We have to find the number of solutions for f of x equals to q. So if we make a straight line at f of x equals to q, we can see that it will intersect the curve at these 3 points. So the number of solutions in this case will be equals to 3. And then part C, it says half of p plus q. So we know that this is the value, this is the amplitude over here is p. So half of p will be somewhere over here. So half of p plus q will be over here. And if you make a straight line from half of p plus q, it will intersect the graph at 1, 2, 3, and 4 points. So there will be 4 solutions for half of p plus q. In part 3, it says for the case where p equals to 3 and q equals to 2, solve the equation f of x equals to 4. Now the expression was p sine squared 2x. So p is 3. So this will become 3 sine squared 2x plus q. So q is 2, and that is equals to 4. Simplifying this, we'll get 3 sine squared 2. So sine squared 2x will be equals to 4 minus 2, which is 2. So sine squared 2x will be equals to 2 upon 3. And taking the square root on both the sides, sine 2x will be equals to square root of 2 upon 3. Now, to find the value of x, first we'll find the sine inverse of square root of 2 upon 3. So that will give us the basic angle. So the basic angle will be sine inverse of, so this will become sine inverse of square root of 2 upon 3. And we'll have to make sure that the calculator is in radian mode, as the domain or the values of x are from 0 to pi. So finding sine inverse of 2 upon 3, square root of 2 upon 3, so that will become, so sine inverse of square root of 2 divided by 3. So that is equals to 0.9553 radians. Now we have the basic angle, which is 0.9553 radians. And the square root basically represents that we can take this basic angle in the positive and negative quadrants of sine, as a square root has a positive and a negative sign. So we will be making 0.955 in the first quadrant. We'll be making 0.955 in the second quadrant, in the third quadrant as well. So sine is positive in the first and the second quadrant. So this is positive in the first and second. But due to the square root, we'll be making this basic angle in the next 2 quadrants as well, which are the negative quadrants of sine. Now, once we have made these basic angles, to find the value of x, the first angle will be, so 2x will be is equals to 0.955. The second angle will become pi minus 0.955. The third angle will be pi plus 0.955. And the fourth angle will be, so the total is 360 or 2 pi. So this will become 2 pi minus 0.955. Now, first writing 0.955 over here, pi minus 0.955 will be equals to, so pi minus 0.955 is 2.186. And we'll write it till the third or fourth decimal place and then round off the final answers. And then pi plus 0.955 will be equals to 4.0965. And then 2 pi, so 2 pi minus 0.955, that will be equals to 5.328. So these are the values of 2x. To find the value of x, we'll divide each of these values by 2. So 0.955 divided by 2, that will be equals to 0.4775. Then 2.1865. So 2.1865 divided by 2, that is equals to 1.09325. 4.0965 divided by 2, that will be 2.048. And we can just add a 2 over here as well. And then 5.328 divided by 2, that will be equals to 2.664. And now, as we have to give our answer to three significant figures, so we can give this answer as 0.478. This will become 1.09. This will become 2.05. And this will become 2.66. Now, this 2x basically presents two revolutions in 360 or 2 pi. However, as our range is only from 0 to pi, so we'll not be taking the next angles as they won't be in the range. Now, all of these answers that we have are within the range 0 to pi, as pi is 3.142. So the maximum value is 2.66, which is less than 3.142. So these will be the four values for x for the solution of f of x equals to 4. In question number 10, the diagram shows part of the curve with the equation y equals to 3x plus 4 to the power half and the tangent to the curve at the point A. The x-coordinate of A is 4. In part 1, we have to find the equation of the tangent to the curve at A. Now, to find the equation of a tangent, we'll need the gradient and the point on the line. So we know the x-coordinate of A. In the first step, we can first find the y-coordinate. So the y-coordinate will be y equals to, the equation of the curve is 3x plus 4 to the power 1 upon 2. So substituting x equals to 4, this will become 3 into 4 plus 4 to the power 1 upon 2, which is equals to 16 to the power 1 upon 2, and that will be equals to 4. So the coordinates of A are 4, 4. Now to find the equation, we'll have to find the gradient of the line. So to find the gradient, we'll find the dy dx of the equation. So the dy dx will be equals to, we'll multiply 1 upon 2 by the coefficient. So that will become 1 upon 2 into 3x plus 4 to the power, so we'll decrease the power by 1, that will become minus 1 upon 2, and multiplied with the derivative of 3x plus 4, which is 3. So that will become 3 upon 2. And now we can bring the 3x plus 4 in the denominator and write it as positive square root of 3x plus 4. Now substituting x equals to 4 over here. So when we substitute x equals to 4, the dy dx will be equals to 3 upon 2 multiplied by, so this is square root of 3 into 4 plus 4. So that will become 3 upon 2 into square root of 16, which is 4. So that will become 3 upon 8. Once we have the gradient, we can now write the equation of the line as y minus y1. The y coordinate is 4. The gradient is 3 upon 8 into x minus the x coordinate is 4. Cross multiplying, we'll get 8y minus 32 is equals to 3x minus 12. And we can simplify this equation to write it as 8y is equals to 3x minus 12 plus 32, which is equals to 3x plus 20. In part 2, it says find showing all necessary working the area of the shaded region. Now, to find the area of the shaded region, first we'll have to find the area under the line or the tangent to the curve at the point A. Then find the area under the curve and subtract the two areas. Now, to find the area under the line, we can see that it is a trapezium. One of the parallel sides has the y coordinate, which is 4. So we'll have to find this point as well, which will be the other parallel side. Now, as at this point, x is equals to 0, and we already have the equation of the line, which is 8y is equals to 3x plus 20. And substituting x equals to 0 over here, as it is on the y-axis. So this will become 8y is equals to 20, and y will be is equals to 2.5. Once we have the second parallel side, the area under the line will be equals to half into sum of parallel sides. So half into the sum of parallel sides will be 4 plus 2.5 multiplied by the height, which is 4. So simplifying this, we'll get 2 into 6.5, which is 13. So the area under the line will be 13. Now to find the area under the curve, so to find the area under the curve, we will integrate the equation of the curve and apply the limits 4 and 0. So the equation of the curve was 3x plus 4 to the power half, and as it is from 0 till 4, so the limits will be 4 and 0. Now integrating 3x plus 4 to the power half, first we'll increase the power by 1. So that will become 3 upon 2. We'll divide it by the new power, which is 3 upon 2. And also multiplied with the derivative of 3x plus 4, which is 3. We can now bring the 2 in the numerator and write it as 2 upon 9 into 3x plus 4 to the power 3 upon 2. Once we have integrated, now we can apply the limits. So the upper limit is x equals to 4. Now substituting x equals to 4 into the equation, we'll get 2 upon 9 into 3 into 4 plus 4 to the power 3 upon 2. And then subtracted from the lower limit, which is x is equals to 0. So this will become 2 upon 9 into 3 into 0 plus 4 to the power 3 upon 2. So this is 16 plus 12 plus 4, which is 16. 16 to the power 3 upon 2. So the square root of 16 is 4, and 4 cube will become 64. So 64 into 2 will become 128 upon 9 minus, and this will become, so 4 to the power 3 upon 2 is 8. 8 times 2 is 16. So that will become 16 upon 9. Subtracting these two, we'll get 112 upon 9. So as in, we now have the area under the curve as well. The area of the shaded region will be equals to, so the area of shaded region will be the area under the line, which was 13. And we'll subtract it from the area under the curve, which was 112 upon 9. So taking the LCM, this will become 9 times 113, which is 117. So 117 minus 112 upon 9, that will be equals to 5 upon 9. In part 3, it says a point is moving along the curve up at the point P. The y-coordinate is increasing at half the rate at which the x-coordinate is increasing. We have to find the x-coordinate of P. Now we know that the rate of change of y and the rate of change of x are related by the equation dy by dt is equals to dy by dx multiplied by dx by dt. Now, as it is saying that the y-coordinate is increasing at half the rate of dy at which the x-coordinate is increasing, so we can write dy dt as half of dx by dt, and that is equals to dy by dx into dx by dt. So dx by dt and dx by dt will cancel out, and dy by dx will be equals to 1 upon 2. Now from part 1, we already have the expression for dy dx. So the expression for dy dx we found in part 1 was, it was 3 upon 2 into the square root of 3x plus 4. So this was 3 upon 2 into upon 2 multiplied by a square root of 3x plus 4, and that is equals to 1 upon 2. So cross multiplying, we'll get 6 is equals to 2 into square root of 3x plus 4. 6 divided by 2, that will become a 3. So that will be 3 is equals to square root of 3x plus 4. Now whole squaring both the sides. So when we whole square both the sides, the square root will cancel out, and this 3 will become a 9. So this will be 9 is equals to 3x plus 4. Now finding the value of x. So 3x will be is equals to 9 minus 4. And x will be is equals to 5 upon 3. So this will become 5. 3x is equals to 5. And x will be equals to 5 upon 3.